Okay, we are going through the logarithm. What we mean by logarithm and why we are using logs or logarithm in mathematics. So let's consider on this example 2 to the power of x equal to 32. Without using logarithm, we can say that x is equal to 5 because 2 to the power of 5 is equal to 32. In other words, 2 times by 2 times by 2 times by 2 times by 2 is equal to 32. However, if the power was decimal or bigger power here, we couldn't easily calculate as we did here. Okay, so let's write down this one in 2 to the power of x equal to 32 in terms of logarithm. We write down log of base 2 of 32 equals to x. So let's use our calculator to see what we get for x if we use the logarithm. Log the base of 2 of 32, which we can clearly see it is equals to 5. Okay, so therefore we can write the formula for logarithm. If log base b of a is equal to c, then we can say b to the power of c is equals to a. That's the main formula for the logarithm. Okay, let's look at some examples. Write each statement as a logarithm. Write each statement as a logarithm. Three to the power of 2 is equals to 9, which gives us log to the base of 3 of 9 is equals to 2, because 3 to the power of 2 is equals to 9. However, for this example, let's use the calculator again to make sure we are on the right process. Log of base 3. Log to the base 3 of 9, which is equals to 2. Let's look at the example B. 2 to the power of 7 is equals to 128. Therefore, log of base 2 of 128 is equals to 7. Because 2 to the power of 7 is equals to 128. 64 to the power of half is equal to 8. Because we know that 64 to the power of half is the same as the square root of 64, which is equals to 8. So we can write down this one in terms of logarithm as well. Log of base 64 of 8 is equals to half. Okay, next example. Write each statement using a power. Each statement using a power. A. Log of base 3 of 81 is equals to 4, which means 3 to the power of 4 is equals to 81. Let's use our calculator to make sure we are right. 3 to the power of 4, which is equals to 81. Therefore, we are correct. B. Log of base 2 of 1 over 8 is equal to minus 3. We know that 2 to the power of minus 3 is equals to 1 over 2 to the power of 3, which is 1 over 8. Therefore, this one is correct as well. Okay, so let's move on to the next part of the lesson. Without using a calculator, find the value of, okay, next example. Without using a calculator, find the value of the following. So, log of base 3 of 81. Let's say it is equals to x. 3 to the power of x must be equals to 81. X is equals to 4. Because 3 to the power of 4 is equals to 81. B. Log the base of 4 of 0.25. Let's say equals to y. So 4 to the y is equals to 0.25. Therefore, y is equals to minus 1. Because 4 to the power of minus 1 is the same as 1 over 4 to the power of 1. 1 over 4 to the power of 1 is quarter, which is equivalent to 0.25. C. Log of base 0.5 of 4, let's say equal to z. So we know that using the logs and indices law, 0.5 to the power of z is equal to 4. Which implies that z is equals to minus 2. Because 0.5 to the power of minus 2 is the same as 1 over 0.5 to the power of 2, which is the same as 4. Next example, log of base a of a to the power of 5 equals to 5. Work out the value of, equals to, let's say, y. Okay, so it would be a to the power of y equals to a to the power of 5. Therefore, y is equals to 5. Now let's look at some buttons in the calculator and show how we can represent actually logs with different bases. We've got 3 buttons for logs. One is this one, which is there is place for the base and also log of whatever number we want to get. Okay, for example, log of base 2 of, let's say, 32, for example, which was our first example, equals to 5. Another one is this one. If you press Shift and this button with the brackets, you get log without any base. Logs without any base means log of base 10. So just to make it easier, we don't write down base 10. So let's say log of 100. We know that it is base 10. Therefore, 10 to the power of something must be equals to 100. The answer must be equals to 2. Okay, as we've got it here. And next one is ln, or we pronounce it ln, which is the natural log. Okay, and the base of this log is e, which is 2.7 and so on. Okay, which we will go through this later on in the lesson. Okay, let's look at for some more examples. Use your calculator to find the following logarithm to 3 decimal places. Example. Use your calculator to find the following logarithm to 3 decimal places. Log of base 3 of 40. So using our calculator, we need to use this button, which has got base as well, base of 3, then 40, which is equal to 3.35776271. Up to 3 decimal places, it would be 3.358. Let's call this one A. Next one B. Log of base E of 8. Okay, let's write down log of base E. E should be one of the buttons here. Alpha is times by 10 to the power of x. If you press alpha times 10 to the x, you will get E, and we are looking for 8 here. So which is 2.079. 2.079. However, we could use this button as well, ln or ln. Let's try this one to see if we get in the same answer. Ln of 8, close the bracket, which is 2.079 and so on, which is exactly the same as this one. So next one is log of base 10 of 75. Log of base 10, 75. So let's use our calculator for this. Let's use this button first. Base 10, then 75, which is equal to 1.875. 1.875. However, since the base is 10, we can use this button as well. So let's press Shift and then bracket. So let's put 75 here without any base, which means the base is 10, equals to 1.875. Exactly the same answer. So after this lecture, you can do exercise 14D from Edexcel textbook, and which is page 320 to 321. However, in next video, we will go through some of the answers from solutions from this exercise, which is exercise 14D.